Hello everyone, hope you're doing well. Today in this class we will talk about a new topic which is limits. So we will take an introduction to limits and how to use and how to find limits in some of these problems. So in this topic we will learn how to evaluate limits. We have three ways to find limits, like by graphs, by numbers, and by analysis of this functions. And we have a new definition which is continuity of a function, and we have infinite limits. So guys, I'm trying to not going deep that much in this class, while I have to just give you an introduction or a small introduction. Why do we need limits? Okay guys, let's take a look at this two problems. So normally when we have a straight line and I'm asking you to find the slope of this line, so immediately you would tell me that I can take 2 points of this line, I can take the slope which is y2 minus y1 over x2 minus over 1 over the difference between x's, and then you will be able to find the slope of this line. And this slope of this line is constant over the line. So basically you don't have to find the slope for each 2 points of this line. Once you found the slope, this is the slope of the line. But let's take a look at the case when we have a function fx, like instead of a line. So in this case, how to find the slope of this curve at this point? So basically, if you want to take any 2 points, you will get a totally different slope, because sometimes you take this P and Q, another time you take P and another point in here. So each time you take 2 points, you will get a different slope at this point. So what should I do? So that's why I need a new concept to define the rate of change of a function, to define how to find the gradient or the slope of a curve at one of these points. And once you are taking 2 points and these 2 points are, or the distance between these 2 points decreases, the slope gets more and more accurate. This is why we need the new definition, which is the limit process, or the distance between these 2 points decreases, we will get a more accurate slope. The second problem, why do I need limits? Guys, when we were in small grades, we used to find the area of a rectangle by just finding the length multiplied by width of this triangle. For example, look at this in this small triangle. If I'm asking you to find the area of this triangle, immediately you would tell me that it's the width multiplied by the length of this triangle, of this rectangle. So you would find the area immediately because it's a constant shape. So for example, if this is L and this is W or delta X, immediately you would multiply, you would find the area. But the problem is, if I'm asking you to find the area under this function, so you have fx, it's drawn, and you are asked to find the area below this fx. How would you find the area? Okay, you have this simple way of taking these small rectangles, and you would tell me, okay, I will take these rectangles and I would start to add these rectangles until I get the area of this under this function. Yes, this is true, but once you make this rectangle bigger, you will get more error in this area. Once you get the small rectangles, you will get less error in this area. So that's why we have this limit concept again. As the number of rectangles increase and the width of these rectangles decreases, the approximation improves for the area of this function. So basically I need to make all these rectangles small as much as I can, because I can get the area under this function. In these two problems, I can say that I need a new concept, which is the limit process, or the limit concept. Once the distance becomes smaller, the slope or the area will get more accurate. This is the concept of the limit. So let's take the first problem and let's take a bigger look at this problem. We have a function drawn and we have the point P and the point Q. So if I'm asking you guys to find the rate of change of this function at the point P, so you would tell me, okay, I would take another point which is Q on this function and I would draw a line. I will find the slope of this line and I would say the slope of this line PQ is the same as the rate of change of this function at the point P. Another one will come and he would tell me, okay, instead of having Q in this position, I would have Q in this position, which is closer to P, and he will get more accurate slope or rate of change of this function. So that's why we define the rate of change of a function, which is equal to the slope, as f, take any point, which is P in this case, which is x, plus small changes. So as if I'm taking another point exactly next to the point P, instead of having Q like in this place, I have another point which is close to the point P, and the distance between P and this point is delta x. Guys, this delta x represents a distance, a change of between 2 points. So I need 2 points. Okay, the first one is x, the second one is x plus small changes with, let's say, the point next to the point P over x2 minus x1, which is the distance between these 2 points, in this case delta x. So we define this as the slope, the average rate of change of this function at the point x. So as this distance goes to 0, because I need this distance to be as smaller as I can, so this change, or this delta x, goes to 0, so I can find more accurate slope. And this is the difference between the slope of a secant, which is this line PQ, and the slope of the tangent, which is this blue line, which is at the point P. So we can define the limit, which is the limit of the slope when this change goes to 0. We call this the slope at the point P of this function, or the slope of the tangent. Again, the limit means we go and we want to make this change goes to 0. So basically, when this amount or this change goes to 0, we can define this as the tangent, slope of the tangent, or the limit of this average rate of change, and instead of having the average, we would have instantaneous rate of change. So this is the basic definition of a limit and why do we need this limit. Thank you guys, hope you enjoyed the class.